Miss Alice.
Hello student, I'm Miss Hajar. I will be teaching you on how to differentiate the types of collisions between two objects.
Hi, my name is Krista.
Hi, I'm Miss Jane.
Before we start our lesson, let us see the learning objective for this chapter, momentum, direct impact, and impulse. First of all, students are able to define momentum and impulse. Second, students will be able to differentiate elastic and inelastic collision. Third, students will understand on how to apply Newton's law of restitution involving one or two particles. Lastly, students will be able to solve the problems using the correct formula for different situations.
Assalamualaikum and good day everyone. Before we start our lesson today, I have a question to ask. Have you ever jumped to the ground from any height and felt pain in your leg when you landed with a straight leg, but the leg doesn't hurt if you bend your knee on impact? This is because when you bend your knee, it lengthens the time of impact and reduces the force of impact. The impact you feel is an impulse force. So, in this video, we will learn about impulse. Just like the situation I mentioned earlier, we have applied impulse in our life without even realizing it. If you ever kick a ball, hit a punching bag, or played sports that involve any kind of ball, apparently, you have been using the concept of impulse. So, what exactly is impulse and what does it have to do with any of those situations? Before we can define impulse, we need to talk about the concept of momentum. Momentum is a measure of strength and a measure of how difficult it is to stop a body. A body that is not moving has zero momentum. A slow-moving large body has a large momentum, and a fast-moving small body also has a large momentum. For example, if a tennis ball and a bowling ball have the same velocity, then the bowling ball has a greater momentum because it is more massive than the tennis ball. Here's the formula for momentum. Momentum represented by the lowercase p symbol, which is equal to the product of mass and velocity. Now, is momentum a scalar quantity or a vector quantity? What would you say? Mass is a scalar quantity and velocity is a vector quantity. If you recall, the vectors have both magnitude and direction. Now, what happens when we multiply a scalar by a vector? A scalar times a vector will give you another vector. That vector could be greater or smaller in magnitude. So, momentum is a vector that has both magnitude and direction. Now, let's talk about the units of momentum. Mass is typically in kilograms. Velocity is usually in meters per second. So, momentum will have the unit kilograms times meter per second. But, how is momentum related to impulse? When a force acts on an object for a short amount of time, impulse represents how much the force changes the momentum of an object. Therefore, we can say that impulse is a certain amount of force you apply for a certain amount of time to cause a change in momentum. The formula of impulse is force multiplied by time. Unit for force is Newton and for time it's typically in seconds. So, impulse will have the units Newton times second. But according to impulse momentum theorem, the impulse is equal to the change in the momentum of the object. So, a force acting on an object for a given time interval is equal to the mass times the change in the velocity of the object. So earlier, we know the unit for impulse is newtons times second and the unit for momentum is kilograms times meter per second. So these units actually are equivalent, but when you see newtons times second, typically it corresponds to impulse. And if you see kilograms times meter per second, that's usually correspond to momentum. But actually, those units are equivalent. Impulse is a vector quantity. So, a negative impulse means the net force is in the negative direction. Likewise, a positive impulse means the net force is in the positive direction. That's all for the definition and formula of impulse. Let's move to the next subtopic.
Hi student! Just now, you have learned what is momentum and impulse, including the formulas given to find the magnitude of momentum and impulse. Now, I, Miss Hajar, will be teaching you different types of collisions that occur between two moving objects. Those two types are elastic collisions and inelastic collisions. Alright, let us hop on to the next slide. Elastic collision. Based on the theory definition, elastic collision is a state where no loss of kinetic energy occurs in the system, which means that the two objects are still moving even after they collide. Well, there are three conditions that might occur after the collisions happened. Let's look at this video. This is the first condition of elastic collisions. Noted that both first and second balls have the same mass, size and velocity. You can see that after the balls have collided, the two balls will change their direction to the opposite side. You can see that the second video shows that the first ball is moving with constant velocity and starts colliding with the second ball, which is in an equilibrium state. Then, after the collision happened, the second ball starts to move in the same direction as the first ball, and the first ball became static after they collided. Thus, the first ball becomes zero velocity, while the velocity of the second ball changes after the collision. The last condition of elastic collision, before they collide, both the first ball and the second ball are moving in the same direction. After they collide, we can see that the second ball moves faster than the first ball. Besides that, you can notice that both balls are still moving in the same direction but with different velocities. That's all for elastic collisions. Let's move on to inelastic collision. An inelastic collision is a type of collision where there is a loss of kinetic energy occurs. The lost kinetic energy is transformed into thermal energy, sound energy, and material deformation. There is only one condition that determines the inelastic collision of two objects. Look at these two cars moving toward each other before the collision occurs. But after the collision between these two cars happened, they stuck together even after they collided. Thus, this proves that the kinetic energy lost is used in bonding the two objects together. It's test your understanding time. Look at this motion. Choose whether it is an elastic collision or inelastic collision. Good. Now explain, why does it call as elastic collision? Yes, because the second particle is still moving even though the first particle stopped after it collides. Okay students, that is all from me. Thank you.
The principle of conservation of linear momentum. What is conservation of linear momentum? Newton's third law stated that every force has an reaction of equal force and opposite direction. Therefore, in a closed system of colliding bodies, the total momentum after the collision is equal to the total momentum before the collision, provided that there is no external force acting on the system. From this, we get the equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Imagine that there are two balls colliding as shown in the video. We can see that in the first situation, green ball stops after colliding with purple balls, and purple balls move to the right from rest position. In second situation, both green and purple ball move to the right but with different speed. In last situation, purple ball moves to the right after colliding with green ball, whereby green ball bounce back to the left after colliding with purple ball. This situation with both balls having different speed after colliding is called elastic collision. Therefore, the formula is m1u1 plus m2u2 equal to m1v1 plus m2v2. Meanwhile, for inelastic collision, we can see from the video shown that after colliding, car A and car B getting dragged together at same speed. This is called inelastic. As both cars have same speed after collision, therefore the formula for this situation is m1u1 plus m2u2 equal to m1 plus m2 times v. Do you understand everything so far? Let's test your understanding. What formula should you use for situation below? 3 seconds. Since the collision is inelastic type, so you can use the formula m1u1 plus m2u2 equal to m1 plus m2 times v. Let's try another one. What formula should you use for situation below? 3 seconds. You can see that the particles bounce from each other after it collides. Therefore, it is elastic collision. You can use the formula m1u1 plus m2u2 equal to m1v1 plus m2v2. Newton's law of restitution states that when two bodies collide, the speed with which they are moved after the collision actually depends on the material from which they are made of. The coefficient of restitution is a unitless measure of how bouncy or elastic an object is. Higher coefficient of restitution means that the object is bouncy. When coefficient of restitution is equal to 1, it means that no kinetic energy is lost. If coefficient of restitution is equal to 0, there is maximum kinetic energy loss. However, both of these situations is only in theory. You can find the coefficient of restitution for one particle by using the formula E equal to V over U, where V is the velocity of the particle after collision and U is the velocity of the particle before the collision. For collision that involving two bodies, you can find the coefficient of restitution by using the formula E equal to V2 minus V1 over U1 minus U2. Remember, the coefficient of restitution is always positive and it lies between 0 to 1. And when you calculate the coefficient of restitution, remember that velocity is a vector quantity. So you have to take the direction into consideration. Do you understand everything so far? Let's test your understanding. Is the statement true or false? You are given 2 seconds for each question. Question 1. Ball A coefficient of restitution is 1. It loses maximum kinetic energy. True or false? It is false. Coefficient of restitution equal to 1 does not lose any kinetic energy. Question 2. Coefficient of energy can be negative. Is it true or false? It is false. Coefficient of energy cannot be negative. It lies between 0 to 1. Question 3. Coefficient of restitution involving two bodies collide can be found using E equal to V2 minus V1 over U2 minus U1. Is it true or false? It is false. Coefficient of restitution involving two bodies collide can be found using E equal to V2 minus V1 over U1 minus U2.
Next, let us try some questions to test your understandings. Questions 1. Impulse. A ball of mass 0.5 kg is thrown towards a wall so that it strikes the wall normally with a speed of 10 meters per second. If the ball bounces at right angles away from the wall with speed of 8 meters per second, what impulse does the wall exert on the ball? Try to do this question on your own and pause the video. Now, let's get to the answer. So first of all, we need to extract the information from the question. So all we got here is m, mass, equals to 0.5 kg. Our initial velocity is u equals to 10 meters per second. And our final velocity is v equals to 8 meters per second. So in this question, we need to find impulse, I. So from our previous lesson, we all know that I equals to ft equals to mv minus u. Since we don't have f or t, and we all have m, v, and u, so we use the formula of I equals to mv minus mu. And then we just substitute the value that we got from the information into the formula, which we get I equals to 0.5 times 8 minus 0.5 times negative 10. Why is it the initial velocity is negative and our final velocity is positive? Because in this situation, we imagine that the ball is thrown to the left. So when we thrown to the left, our initial velocity, when at the x-axis, x going to the left, it's negative, right? So our initial velocity is negative 10, and when the ball bounces back, it's bounced to the right. So that's why our final velocity is positive, which is positive 8. And then we just calculate it, and we got our impulse I equals to 9 Newton second, 9 ns. Question 2. Elastic. Two particles K and L of mass 0.5 kg and 0.6 kg respectively are moving along in the same straight line on a smooth horizontal surface. Initially, K is given a speed of 2.4 meters per second towards L, and L is given a speed of 1.6 meters per second toward K. In the subsequent motion, K and L collide, and K is brought to rest by the collision. Calculate the kinetic energy loss in the collision. Try to do this question on your own and pause the video. Then, let's get to the answer. So first of all, we have to extract all the information that we can get from the question. So here K is particle 1 and L is particle 2. So mass for K is m1 equals to 0.5 kg, and our mass for L is m2 equals to 0.6 kg. So, and then our initial velocity for K, u1 equals to 2.4 meters per second, and our initial velocity for L equals to negative 1.6 meters per second. Why is it negative? Because it says in the question that K moved toward, so we assume that K moved toward L. K is on the left and L is on the right. And then our K moved toward L, which makes the initial velocity positive, and then it says in the question that L moved toward K. So when L moved toward K, it's moved to the left, like I said before. If it's moved to the left on the x-axis, it is negative. And then next, our final velocity for K, V1 equals to 0. Why is it equals to 0? Because it says that after the collision, K is brought to rest. And then we don't know our V2, which is we don't know our final velocity for L. So from our previous lesson, we know that elastic formula is m1u1 plus m2u2 equals to m1v1 plus m2v2. Here we need to use this formula to find our V2. So we just substitute all the information that we get from the question, and then we substitute into the formula, which is 0.5 times 2.4 plus 0.6 times negative 1.6 equals to 0.5 times 0 plus 0.6 times V2. And then our V2 equals to 0.4 meter per second. After we got our V2, then we move to our main objective, which is to find our kinetic energy loss. The formula for kinetic energy loss is kinetic energy before minus kinetic energy after. So we have to find our before and after kinetic energy. So here our kinetic energy before equals to 1 over 2 mu square. Then we just substitute all the information that we get from the question into the formula, which we get kinetic energy before equals to 1 over 2 0.5 times 2.4 square, which is for the K particle, plus 1 over 2 0.6 times negative 1.6 square, which is for the L particle. And then we calculate it, we get our kinetic energy before equals to 2.208 joule. Next, we find our kinetic energy after, which is equals to 1 over 2 mv square. Then we substitute all the information that we get before into the formula, which we get kinetic energy after equals to 1 over 2 times 0.5 times 0 square plus 1.2 times 0.6 times 0.4 square. And then we calculate it, we got our kinetic energy after equals to 0.048 joule. Lastly, we just substitute our before and after into the kinetic energy loss formula, which we get kinetic energy loss equals to 2.208 minus 0.048. And our final answer for kinetic energy loss is equals to 2.16 joule. Question 3. Rebounds. A tennis ball, which may be modeled as a particle, is dropped from rest at a height 90 cm onto a smooth horizontal plane. The coefficient of restitution between the ball and the plane is 1 over 2. Assume that there is no air resistance and that the ball falls under gravity and hits the plane at right angles. Find the height to which the ball rebounds after the first rebound, after second bounce, and the total distance traveled by the ball before the third impact. Try to do this question on your own and pause the video. Let's get to the answer. So like what we do before, we extract all the information that we can get from the question. So here our coefficient of restitution is E equals to 1 over 2. And then our S equals to 90 centimeter. We have to convert to the meter, which we get 0.9 meter. And our initial velocity is 0 meter per second because we drop it at rest. So in this question, it required us to find the max height for our first bounce. So in order to find the max height for our after the first bounce, we have to get the initial velocity. The initial velocity can be the final velocity for the first drop. So here we use the formula of v square equals to u square plus 2as. Since all the information we get is the acceleration, which is equals to the gravity, our s is 0.9 meter and our initial velocity is u. So we just substitute the information that we get into the formula. Then we get v square equals to u equals to 0 minus 2 times 9.81, which is the gravity, times negative 0.9. Then we just calculate it. We got our V1 equals to 4.2021 meter per second. Next, we use the formula for coefficient of restitution, which is equals to V over U. And then we equalize it with our given value of E, which is 1 over 2. So here is 1 over 2 equals V2 over 4.201. V2 here is our final velocity after the first bounce, and then like I said before, the V1 is our U2, which is the initial velocity for the after the first bounce. And then we got our V2 equals to 2.1011 meter per second. Then we want to find our max height after the first rebound, which is our final velocity equals to 0. So here we're using the formula of V square equals to U square plus 2AS. Our V here is 0 equals to 2.1011 square plus 2 times negative 9.81. Why is it negative 9.81? Because it bounces upward and against gravity. And here our S is our H. S is for x-axis, H is for y-axis. So we just calculate the answer. We get H equals to 0.225 meter. Next, we want to find the max height after the second bounce, but we don't have the initial velocity to substitute into the formula. So in order to find the initial velocity, we use the formula of coefficient of restitution, which is 1/2 equals to V4. Why is it V4? Because our V3 is 0 over 2.1011. And then we get our V4 equals to 1.0506 meter per second. Same thing, max height V5 equals to 0 using the formula of V square equals to U square plus 2AS. Our V5 equals to 0 equals to 1.0506 square minus 2 times 9.81. Why is it positive? Because it's going down and it doesn't against the gravity, and our S is our H, which in y-axis. And then we got our H equals to 0.0563 meter. Lastly, it wants our distance traveled. So our distance traveled equals to 0.9, which is from the rest, which from the start. The rest, it drops, the height is 0.9. And then plus 2 times 0.225. Why is it times 2? Because it drops 0.9, and then up 0.225, going down again 0.225, which is times 2. And then plus 2 times 0.0563. After it's 0.9, 0.225, 0.225, it's going up again 0.0563 and going down again 0.0563. So the total of this distance traveled is 1.463 meter. Question 4. Our last question for this topic is for inelastic. A particle R of mass 2 kg is moving in a straight line on a horizontal table. It collides with another particle S of mass 1 kg moving in the same straight line on the table. Immediately before the collision, the speed of R is 5 meter per second and the speed of S is 2 meter per second. The particles are moving in the same direction. In the collision, the two particles join together to form a single particle T. The table is rough and the coefficient of friction between the table and T is 2/7. Find V and distance traveled. Try to do this question on your own and pause the video. Let's get to the answer. Why we say this is an inelastic question? Because in the question it says that the two particles joins together after the collision, which we know there's only one final velocity. So first of all, we have to extract the information from the question, which we got our mass of R, mR, equals to 2 kg, our mass of S, ms, equals to 1 kg, our initial velocity for R is 5 meter per second, our initial velocity for S is 2 meter per second, and our coefficient of friction is equals to 2/7. So from our previous lesson, we know that the formula for inelastic is m1u1 plus m2u2 equals to m1 plus m2 times v. So here our R is particle 1 and our S is particle 2. So here become mrur plus msus equals to mr plus ms times v. Then we just substitute the value that we get from the information into the formula. Then we get 2 times 5 plus 1 times 2 equals to 2 plus 1 times v. Then we get our v equals to 4 meter per second. Next, in order to use the formula of v square equals to u square plus 2as, because we want to find the s, we have to find the acceleration along the x-axis. Here we can use the formula of F equals to ma. Our F here is our friction force. Our friction which we get our negative friction force equals to MA. Why is it negative? Because our particle moved to the right and our friction force is to the left. That's why it's negative. So we all know here that friction force equals to coefficient of friction times R, normal force. So first we have to find our normal force. Our normal force is R minus 3G equals to 0. And G here is gravity. So our R here is 29.4 Newton. Then we substitute our R back into the formula. We get our coefficient of our friction is 2 over 7. So our negative 2 over 7 times 29.4 equals to 3A. 3 is our total mass of two particles because it joined together after the collision, right? And then lastly, we got our A equals to negative 2.8 meter per second. It slows down after they collide. That's why it's negative. Then we substitute our A into the formula of V squared equals to U squared plus 2AS. Our V is 0 because they stop at rest after the collision, equals to 4 squared plus 2 times negative 2.8 times S. Then we get our S is equals to 2.857 meter.
It's time to recap. After all of these lessons, you are able to use these kinds of formulas based on given situations. To find impulse, you will use J impulse equals to force times time, or the product of mass and final velocity minus the product of mass and its initial velocity. Alright, while finding the momentum of two collided objects, you must remember to use this formula. Last but not least, to find the coefficient of restitution, remember to use it depending on the situation where it involves one particle only or two particles.